here so we can get this show rolling, and we'll be able to post this up to our YouTube channel for you guys to reference back to, and for everyone that registered that's not here, which is a fairly large number. We'll be able to come back and watch it after the fact. Oh, hang on, let me mute everyone. Yeah, that's the only problem is when people log in. It doesn't have a way for me to automatically mute them. So anyways, hope everyone can hear me okay. If you can't, just put a message through in the messenger and GoToMeeting and let us know. But again, so we're here to talk about the probing module within GibbsCAM. That was added in our previous release. So had a little bit of time with it. We've got a decent amount we can talk about here. We've got quite a few cycles that are automatically built into the GibbsCAM interface on the probing side. We've got 2 tiers to probing essentially that we'll kind of cover. Again, we're not going to dive really heavy into all the cycles, but we're going to show them. We're going to show the layout of probing within Gibbs and kind of explain, how it's going to work for you as the end user. Now, benefits to probing, pretty darn straightforward. It's a time saver. It's a money saver. I mean, if we can catch issues on the machine before we ever get that part off, we're going to be a lot better for it. And then the real benefit as a programmer is it's a fail-safe for us in a lot of ways. And the really nice thing with the Gibbs world is we can simulate all of it. So if we go from and again, I apologize for these names. They didn't really talk to us about the naming. So we ended up with 2 names that are about as redundant as it gets. We have basic probing, which is at its simplest form, very similar to our add G-code capabilities within Gibbs. Now it does have more functionality than add G-code, but it's very similar for those of you that are familiar with the ability to just insert lines of code, which in this case, what we're doing is inserting probing cycles within our program. So it's not going to fully simulate the cycle. It's going to go to the given probe point and call it a day. And then the next step up is what we deemed generic probing. Again, I apologize. Basic and generic are frickin' synonyms, and they didn't even think to change it. So, but it is what it is. We're working with it. The generic probing is the full functioning probing module. That is the ability to have the probing cycles built into Gibbs. So you're not messing with code whatsoever. You're just selecting the probing cycle within your process dialog. And it goes ahead, does the cycle based off of the geometry or the surfaces selected, and we get to watch it render in full simulation. So I'm going to let Dave take control and show the various cycles as we run through them. If you guys have questions or anything on this, throw them into the chat section of this, and we will take a look at them. I'll kind of try and stay on top of those questions as we're reading through this. And again, we're trying to keep this in the 15 to 20 minute range, so this isn't going to be completely comprehensive. So by all means, if you have more questions after this comes to an end, call us, email us, whatever works for you guys. So without further ado, I'm going to let Dave take control.
Okay, you guys should be able to hear me now.
Yep, we can hear you, Dave.
All right, as Zach was saying, we're going to start off with and I forget the naming myself most of the time, with the basic probing. So I've got just one process up here. If I open up this process, this is just all hand-coded. And the thing that's nice about this is in the add G-code back in the day, you had to add quotes in here. You don't have to do that at all, but you can just basically copy your cycles and paste them into here. And the nice thing about this also is you could save this probing cycle just like a regular process. So I could save it as a process list and just load it whenever I wanted to. So then when we go to actually simulate, there's that operation over here. If I go into here, I'm going to turn off a lot of this so you can see. This is just going to go position the probe and then run your code from that cycle. Now, all you need to do here is pick a point. It's kind of hard to see there, but there's the the little rapid to or feed from that point. And all I did was select that point, go redo. And that's the basic probing. Let's get into the more advanced stuff here. We're going to go to generic probing. And I've kind of came up with one part that I can show a little bit of everything on rather than jumping around a whole lot. So we're going to start off with, if I go in the probing cycles here, we're going to start off with corners. And the way corners works is it looks at your document control here at the stock size, and it's going to find a corner based on that. So if I double click this first stop and bring it up, we've got a feed rate, probe touch time, which you could plug in a number of seconds that you would like. From my understanding, this is pretty much a standard for Renishaw probing, is to rapid to about 400 thousandths. But we're doing an outside corner. We're setting a work fixture offset. This would be whatever you'd want to type in for whatever WFO you would like. And XY clearance, which is how far away we're going to position the probe before it comes into touch. And this is what corner do we want it on. We also have an X distance and a Y distance. So here I've got 1 inch, which means it's going to come over 1 and 1 and Y, and a Z distance, which the probe's going to go down a ½ inch in Z. If I switch corners here, just click redo. It's just that simple. It's going to probe that side. Let me move this out of the way a little bit. This side, or this side. So that's outside corner. Let's look at the second one. This is outside corner with angle. So if you had, let's say, a 10-degree angle on here, you would be able to do 2 hits in X, 2 hits in Y, and pick up the angle on that part. Also setting a work fixture. And once again, you could set this to whatever you want. And the third one, there's only 3 in this process. The third one is single surface corner Z. So all we're doing here is saying, here, XY clearance, what we want to go to, what the probe depth. In this case, we're just touching the top of the part. We're setting a work fixture. The axis is going to be Z. And we click redo. And it's just, as you see here, the probe is touching just the top of the part. And it works the same way with this. It's just a matter of what corner you want to touch. And once again, this is all based off of your stock. Let's go into just a few more cycles here. So what I've actually done here is I've created another coordinate system over here just to show this, and I've milled a flat here on top. And then I wanted to go probe the top of that. Now, as you see, I'm using slice plane on this. You have the option to either pull off hard geometry or use slice plane. So either one will work with the probing. It really doesn't matter where I have the slice plane at. It's still just probing the top of the part in this case. So now we're just probing I'm sorry, I should have told you this ahead of time. Show you the cycles here. We're going on to shapes because we just finished corners. So this is going to be in the shapes. So this first one here is single surface. I'm just selecting the circle here. I've milled this flat. The hole's not in here yet. I just said, here, set work fixture offset 2. And if I post this out, you can kind of see here, if I go to operation 5, it's offset 2. If I change that to 3 or 4 or 5, that's going to automatically update. Let's process it again. Go to op 5. We're at S4. Okay. So there's our probing code here. So then we drill a hole, we ream a hole, and then we want to measure the hole. I'm going on to the next one, which is circular pocket. So here we're just filling out a feed, a probe touch time, what we're wrapping to and from. We're going to set a work fixture offset here as well. And we're going to do offset 2, whether you want to do 2-touch or not. Now, probe depth, GibbsCAM automatically takes the diameter of the probe and goes, the radius of the probe rather, and adds that to the depth. So if I go minus 0.05, the side of that probe is going to be 50 thou down. And if you look here, this is a 6 millimeter probe. It's not a very large hole compared to the probe itself, but we're hitting 3 points on this at a depth of half the probe plus 50 thousandths. We're doing 3 points. So we could do 3 point, 4 point, and if we do 4, it's just going to do evenly all the way around. If we go 3, you can set this at any angle that you would like to touch. So you could have a circle where, let's suppose part of this circle was cut out. I could do here, here, and at the bottom if I want, just by changing the angles. And by the way, you also need to be in the correct coordinate system. In this case, this is on a 5-axis machine. So I'm on CS2. Let's move on. Over here, we're drilling a hole. And I'm going to skip a couple of ops ahead because I want to explain this. But we're going to probe this elongated hole. If we look here, we're probing this elongated hole after I milled it. And we're using a rectangular pocket, okay? We just did a circular pocket. We're doing a rectangular pocket now. And here, instead of setting a work fixture, which would be here, we're going to set we want to measure rather than set a work fixture. So we have these go-to statements. We can say if it's undersized by 1,000th, then we can go to this statement, this go-to statement, and recut the part. So basically, that's what this is over here. So I've put this beforehand to where if this measures undersize by 1 thou or 2 or whatever I want to set it at, it's going to jump back to here, recut it, and then remeasure it again. You can name these, by the way, anything you want. So if I double click here, let me clear this out and show you where this comes from. We've got this, it's actually under utilities. So you'd go to, and then type whatever you want. There's really no rules that I've found. There might be a limit on length, but I haven't found it yet. So, and then you would just click do it, and it would appear over here on the right like a regular process. So in this probing cycle, once again, I'm using slice plane, but I could just as easily use the geometry. We're saying if it is undersized by 1 thou, go recut it. If it's oversized, alarm out by 1,000, okay? You also have the ability when you're checking a rectangular pocket to do X only, Y only, or X and Y as we're doing in this case. So it's really straightforward. Then we're doing a helix down here. I'm not actually measuring that. I have another go-to statement here, which is measuring a different, it's a 375 bore. This is for this go-to. And it's going to be before you actually mill that hole. And then we go here to measure it. And we're saying circular pocket, measurement, go to 375 bore if it's undersized, alarm out if it's oversized, or you could have it do a go to as well, or continue, or whatever you want. Here we've set a few different angles. We're going to go ahead and drill some holes. This is just some toolpath I threw in here. And we've got a few more measurement cycles to discuss here. This one here, I've gone onto a rectangular pocket We've done single surface, circular pocket. Let's go rectangle pocket. And we're doing a measurement. Undersize and oversize is set here. The probe depth, and we want to check the x-axis. So in this case, it's just going to go back and forth to measure this. The next one, I wanted to measure this wall. So I can do a single surface measurement, which is back to the first one. And I just pick this line. I want to go in the y direction from the negative side. So you have the choice of negative, positive, and some drop downs here as well to select which axes. And it goes ahead and does the measurement. Then if you want to probe on a different CS, you have to create that coordinate system, which I've done here. And I drilled this hole, and then I just wanted to measure it. So it's literally as simple as make sure you pick that coordinate system. We're doing a circular pocket, 3-point, set the angles. And I'll show you what this looks like when we simulate here shortly. Now, the only two that are left really are circular boss. So here I'm going circular boss, which would be measuring from the outside. And once again, here we're doing a measurement. Here's the probe depth, the boss clearance, which is how far away. And we're doing 3 points. And if you look, this is kind of to avoid hitting this slot in here. I want to measure this from here, here, and here. So I chose 120, 60, and 270. And that will get it for me to measure that circular boss with the slot in it. The next one here is a rectangular boss. This is all really straightforward, fellas. It's really not hard, but essentially we're selecting a shape here, which would be our boss. Once again, we're doing a measurement. We've got our probe depth set, our boss clearance, we're going X and Y. If I only wanted to measure width, I could just go X, redo it, it'll measure those. If I want to go Y only, redo, it'll measure that. So really straightforward. So then when we go to simulate, it's going to be different than the basic probing from the standpoint. Let me pick our machine here. Hang on, this will take a second to load. Come on. Got my machine on. Here we go.
Dave, I don't think you were pedaling fast enough.
Yeah, it's still not showing my machine, but I'm not going to worry too much about it. So here, this was a touch off as if the stock were a, let me switch, go to the body bag here and switch this to part. As if our stock was a rectangle, which was the first 3 ops here. So if we go here again, rewind. Now we have a rectangle stock. And you're going to go see the touch-off points here. By this little magenta star shape, and we touch the top. Let me switch that other one back to part stock. Carry on. Let me load the regular VNC file. So I know I had the machine set up here. Okay, here we go. I might not have saved it in my pack and go. Slow this down a little bit, rewind. So it's doing it as if it was a square stock again. This was the angle one, which gave 2 hits. Then we touch off the top surface. That was as if it was a rectangle. Now we're rotating down. Going to machine this. Probe the top. Drill a hole. Ream a hole. And then measure it. Now we could measure top and bottom of that hole if we wanted as well. And so here we're doing that elongated slot. Let's speed this up a little bit while it does that. Probe that. And skip ahead on this one because I don't think I probed it. Oh, I did. It's this one I didn't, but. And then we would go ahead and process it. And here's our probing cycles within the software. And that's about all I've got for this. It's down and dirty, but you can see it's pretty straightforward to use. So Zach, if you want to take it from here.
Yeah, thanks, Dave. Actually, one real quick thing, just to reiterate, this has nothing to do with probing, but since Dave is on a posted on program right now within the Gibbs editor, you can click on the operation from the operation list on the right-hand side of the G-code editor, and it takes you directly to that operation in the code. Something silly, but I just really like it. It just adds to the usability of that side of the software. So anywho, especially when you're doing probing stuff. So, but beyond that,
not only that,
not
only that, Zach, on the MTM side, if you have 2 flows, multiple flows, we show both flows where we would go synchronized and have the choice of picking a different weight codes to display. So it split the screen in half. So that's pretty powerful as well.
Absolutely, absolutely. Okay, we actually did have a quick question come across. Let me see if I can find it here. Oh, actually, sorry, 2. Mike Clodfelter. Mike, I hope you're doing well, man. It's good to hear from you. He is asking, where do you store the probing inspection data? That's actually a good question. We've gotten that a couple times from the start of this one. So Dave, correct me if I'm wrong, but it defaults to the location in the control where it is by native stored. So it's going to be different on each machine or control, but that's where it goes.
Yep.
All right, next one from Raphael. Is there a machine offset tool compensation ability?
Oh, to measure and comp your tool.
Yes.
I'm sure that's all contained within Renishaw cycles.
That would be my, yeah, sorry, Dave.
Yeah, actually, Mike would be the best one to answer how that works, Cloudfilter. But yeah, it's you've got to be able to comp your tool out and recut it. So that's not on the Gibbs side. That's got to be on the Renishaw side itself. So basically, any of those kind of questions, we are only going to Renishaw cycles that are available, if that makes sense. It's not within GibbsCAM.
Yeah, and so something else.
If Renishaw has a cycle that does that, then we can support that.
Yeah, exactly. And something to bear in mind is this is still relatively in its infancy in terms of a Gibbs module. So we're still developing, and if you have certain cycles that you see that are pretty commonly used, we don't have a problem going back to development. I mean, hell, the only reason this module even made it into Gibbs is because of us and our customers. So, and I mean that very literally. So if you have things that you're like, man, it'd be really helpful to have this in there and we can make a good case for it, I have no problem going back to development and anyone else that I have to complain to get stuff added into the software. But the gist of it is we support pretty much all of the cycles that are currently out there. And, we can always grow and add for the generic side, the more comprehensive side of the probing within Gibbs, we can always add that stuff in. So it just becomes part of the drop down in the process tile. So hopefully that answered the question as best as we can right now, Rafael. Yeah. If anyone wants to take a look at probing more in depth, by all means, let us know. We can set you up. Actually, I know Kyle is on here. We can set you up with an evaluation copy of this and let you kind of mess around with it yourself, get a feel for it. So just whatever you guys need, don't hesitate. Trying to think if there's anything else. One more thing I did want to address before we get off of here. So the 2 tiers, the basic, which is the more closely in line with kind of copying and pasting your cycles into the Gibbs program. That is fully supported. Any post you have, any post that's supported. It's just a native functionality of Gibbs. We may have to add the ability to read the G code into the post, but that's a pretty simple job, and it's not something that we have to worry about any additional time or anything like it. It's considered a standard portion. The generic side, which is the more comprehensive, that has the built-in cycles and all of that does require some post work. Now we have a handful of posts that we've already done this to, and then we also have a handful of what we would call starter posts for the bigger OEMs out there. So we wouldn't be starting from ground zero by any stretch, but just know that if you have very specific cycles you want to see added into it, there will be a little bit of post work involved in that. But that's all part of the pricing when we add the probing into your software. That would be part of that price. It wouldn't be additional after the fact. So yeah, if anyone has any questions about this, hang on, make sure I'm not missing anything. Okay, I think we're good there. All right, well, hey, I appreciate everyone taking the time today. I hope you all have a great day. If any wicked storms come your way, I hope you stay safe and enjoy a little bit of this warm weather. And if you're a Cincinnati Reds fan, I'm sorry about what the Indians, and I will not call them the other name right now, did to you. So I hope you all have a great one. Enjoy the rest of your day. And don't forget, this will be posted up to our YouTube channel probably by the end of today. So thank you again, guys. Have a great one, and we will talk to you all soon.